this tutorial we're going to be tweaking the motion of our particles in our particle simulation here that we were working on in the last tutorial, just to make it look rather more interesting. So let's go to particle.cpp here. So if we look at this at the moment, one of the problems with this is the explosion looks too uniform, especially in the early stages. All the particles have a speed that's sort of uniformly distributed, or somewhat too uniformly, between the middle of the circle and the outer edge. And that means that it has a rather sort of blocky, circular appearance, especially when it starts out. Now, one thing we can do to change that is, in the particle constructor here, we're assigning a speed to the particles, and we're giving that speed a uniform random distribution between 0 and some figure that we've decided on here. What we can actually do is simply to square the speed. So I could say m underscore speed equals m underscore speed times m underscore speed. Or, more succinctly, the same thing can be written as m underscore speed times equals m underscore speed. Now, if we look at that now, it's going to probably be much too fast. In fact, we don't. I think we've got a tiny glowing spot in the centre, which is probably the remnants of the particles that haven't shot off the edge. Let's try changing this to a much bigger figure, this constant that we use in deciding the speed. See how that looks. So I think it's still much too fast, and what we're seeing now is just the remnants of the particle in the middle there. Let's add a 0. So we need to experiment a bit to find a good value now for speed. And I think that looks quite a lot better. So if you look at this explosion now, you'll notice it's a lot more ragged. And the reason for that is that by squaring the speed, we've meant that the average distance between the particles increases as you go from the inner edge to the outer edge. Well, this is putting it in language that's a little bit loose mathematically, but we get basically a different distribution, which exaggerates more the distance between the particles as you move towards the edge, which I think looks quite a lot nicer. Now, another thing we can do is give the particles a bit of curl. So let's go to the update method here. And before we calculate the x and y components of the speed using the speed and direction, we can add something to the direction to make the particles curl around a bit. Let's say m underscore direction, and we'll use the plus equals. We'll use the interval in here to ensure that this happens in a similar rate on all different systems. So interval times, and we need to put in some sort of constant here, which I don't really know what it should be. Let's try some figure like this, which might be good or might not be. Let's try running this and see what happens. So now the particles are curling rapidly, and indeed this thing is imploding a bit. Let's try something a lot smaller. I'll put another 0 in there after the decimal point. And still very rapid. Let's try another 0. See how that looks. We want something a little bit subtle. So these still seem to be spiraling very, very rapidly. Oh, yeah, because I've written 4 instead of 0.00. Apologies. Let's try something more sensible like this. Okay, let's try this. So yes, now we've got a subtle curl there, relatively subtle. The explosion is still sort of imploding in on itself, and we need to do something about that. One thing we could do is just try a slightly smaller value still, but we're going to have to fix something else here, I think. Yeah, so now the curl is so subtle that you don't even really see it. So I quite like this sort of a value, I think, but we want to change something here to make this a bit more interesting. So there's a couple more things that we could change here. Actually, there's sort of an infinite array of things that we could change. But what I'm going to do is I'm going to check in this update method if the particle goes off the edge of the screen. Because if it does, there's not much point still drawing it. It might spiral back to the centre, but who knows really what it will do. It's going to be more interesting if this particle goes out of its nominal kind of allotted particle space, which we decided would run from -1 to +1 in the x and y directions. Then we can reinitialize the particle, put it back at the centre and choose new random values for its speed and direction. So let's say here, if m_x is less than -1, or it's greater than 1, or m_y is less than -1, or m_y is greater than +1. Now we want to reinitialize the particle with some more random values. Let's create a function up here called init, or a method I should call it technically, because this function is part of a class. Let's put the code from the initialization code from the structure from the constructor into init, and also initialize the initial location of the particle in there. And then in the constructor we can just call init. And we need to add the prototype to that in particle.h as well. I notice here I've got a public section for my functions, but that's sort of superfluous really. Because in a struct rather than a class, everything's public by default anyway. But it does sort of help to separate visually the methods from the variables a bit. What we can do is have a private section in here to put the speed and direction in. And I'm going to make my init method private as well. Let's have another section for this because it's a function, just to visually separate it from the variables. So that's void init. And let's try running that and see how it looks now. So now I think this is rather more interesting. And for some reason that I'm not sure about, I was going to say that it reduces the tendency of the particles to implode, but that seems not to be the case after all. So I don't really know why it would. But it does look, I think, more interesting. Maybe even a bit less curl. Let's try 0.0004. Oh, that would be more. Let's try 2, see how that looks. Oh, I didn't even call init. Okay. Well, I got to sleep at 7 AM last night for some reason. Oh, that's my excuse. Okay, let's try it now. Yeah, in fact, I think what happens is the particles tend to go off the edge of the screen, but then they reappear in the centre. And that does seem to somewhat reduce, as far as I can see from looking at this now, the tendency of the whole thing to implode. Yeah, because particles that eventually go off the edge, they start springing out the centre again later. Don't know if it would implode, shrink to a point in the centre if we let it run long enough. But one last thing I think that we can do here is we can take a portion of the particles at any given on any given refresh and just reinitialize those randomly. So let's say if rand is less than rand_max divided by 100. So here rand max is a large integer which we're dividing by 100, and rand is going to be an integer from 0 up to rand max. So if we say that it's got to be less than 100th of rand max, that means 1 in every 100 times this runs, it's going to be true, and then we can just do an init, which is going to reinitialize. some of our particles randomly. Now actually this program is not completely independent of the processing power of your computer, because the blur is basically running as often as it can within our game loop, and also this random reinitialization will happen kind of just as often as it can, because we're not using the interval in any way in there. But that probably doesn't matter too much. What we've got now is something that I think is much nicer. I don't know how well it shows up in my screen recording here, but what I can see here is the particles around the edge of this thing really sort of look like they're seething in and out of sort of massive molten lava or something. It's kind of like the surface of the sun, which I think is really interesting. Now I'm going to leave this program there now, so we're finished with coding in this course. You could do a lot more things to make this even more exciting. This is my favourite bit, by the way. You're getting some colour variation here, because the results of the blur are left behind after the new particles have changed colour, and it's this colour variation that gives this a lot of its excitement. But what you could do is you could, in the update method of the particles, you could alter the colours of the particles separately, but hopefully in such a way that they're sort of harmonised with each other, or particles that are close by each other maybe, or have similar speeds or whatever, have similar colours as well. But you could try doing something like that to create more striking colour effects by having more colour variation among particles. That could be interesting. Well, in fact, the great thing about this program, if you like visual things, if you're a visual person, is that it really does inspire you to just tweak it and try all kinds of new different effects. So that's it for this tutorial, and indeed that's it for the coding part of this course. I'm going to add probably, I don't know, one or two more videos just explaining a couple more things here, and we're going to take a look at the various kinds of C's that are on offer: C#, C++, Objective-C, and so on. If you've actually followed through this course, well, even if you've watched the videos, congratulations. If you've actually coded this stuff and got it working, then seriously big congratulations. Hopefully this will have improved your C++ a lot. If you were a beginner when you started the course, then this is an amazing achievement to have got through all this. You're not going to be a completely fluent programmer yet. To be that, you have to practice writing your own programs a lot. You have to think about how to design those programs and experiment with different ways of coding, different ways of designing. Find something that works for you and just practice it endlessly. But hopefully you are now in a position that you could go ahead and start writing programs of your own, and you'd have an idea of how to do that, even quite complex programs like particle simulations. So big congratulations. Most people who start a course like this, the vast majority, never get past the first few lectures, I can tell you, which I guess is the same with a textbook. Okay, so that's it for this tutorial.